Morning, everybody. This is Mike Human. I'm the Chief Analyst at G2M Research, and thank you for attending our G2M Research Spring 2018 Market Sizing Webinar. I'm forgetting the title there for a second. Just a couple of things before we start into the meeting. If you have any questions, please put them into the Q&A section on your web or on your Zoom controls. That way we can get the answers to you. We'll also have two poll questions that we'll go through. So once we do that, we will give you a second to answer each one of those, and we can kind of take it from there. Jumping in, let's just jump straight into the stuff. So kind of key highlights from this semi-annual version of the report. A lot of growth in the NVMe ecosystem. The number of NVMe SSD models and series has increased 43% in the past 6 months. So that's almost 50% growth in that area, which is pretty impressive. Another fact, I think, talking to the health of the NVMe ecosystem, is that every major all-flash array company, including Dell EMC, HP, NetApp, and Pure Storage, all have NVMe or NVMe over flash-based arrays available now. Similarly, on the number of NVMe servers has increased by 151%. We've seen several new models come out from Dell and HP, as well as entry into the space by several of the Taiwanese motherboard manufacturers, actually selling total servers. Similarly, the number of storage appliances has increased by 62%, and that's all since the last 6 months. And one of the biggest growth areas is in NVMe adapters. So there are a significant number of NVMe adapters available now, more or less the same companies. SolarFlow has entered this, and we'll talk a little bit more about each of the companies, but the number of models that have been that are being provided increased significantly. So from a revenue standpoint, this is what the NVMe ecosystem looks like. So we expect that the revenue for the NVMe ecosystem will be about $65 billion by 2021. As previously, about half of this is servers, but as you can see, both the storage arrays, storage appliances have grown significantly, as has the actual NVMe storage devices and NVMe over flash or over fabric adapters. So to kind of give you a little bit more feel for kind of the health of the market right now. So if you look at the NVMe SSDs, there's 23 companies now offering NVMe solid state drives. That's up by 2. There's 96 different models available. That's up by 29. So quite a large increase there. Servers, again, 13 companies now offering them. That's an increase in 4. There's 93 models. That's an increase in 56 models from the ones that were available 6 months ago. In the all-flash array space, there's now 11 companies that offer NVMe all-flash arrays. That's up by 3 from previously. And there's 21 models. That's better than doubling what we saw even 6 months ago. NVMe appliances, we have 8 companies that offer NVMe appliances now, storage appliances. That's up by 1. There's 21 models, again, up by 13. So lots of growth in all those areas. For NVMe over fabric, HBAs, NICs, and RNICs, so non-accelerated ones, 5 companies, pretty much the same 5 companies as previously, a total of 53 models. And then for accelerated adapters, those that provide significant offloads, typically implemented with FPGAs or system on chip, there's 6 companies. That was an increase in 1 from the previous 6-month report. So some of the top forecasts for the NVMe market, I'll talk a little bit about these. We talked a little bit about the market size. Again, some of the other ones, from the server perspective, we expect that over 50% of servers will be NVMe enabled by 2019. That means they'll either have U2 bays in them, or they will have ruler-based storage devices. We expect there to be an average of 5.6 U2 bays per server in these devices by that time. From the storage appliance arena, we expect over 70% of all storage appliances will be NVMe enabled by 2021. with the average storage appliance having about 30 U.2 or ruler NVMe SSD slots in it. On the all-flash array side, we expect that NVMe over flash will become the predominant media for all-flash arrays by 2021, and we expect that half of the NVMe over fabric revenue will come from accelerated or offload SmartNICs that actually get sold and put into these arrays to act as target devices. We also expect that over 70% of all flash array host connects will be NVMe based by 2020, and we expect that NVMe by that time will also be the predominant backend fabric, largely replacing InfiniBand and SAS or SATA in the connections between the controllers and the JBOFs. And last but not least, we expect that over half of all enterprise SSDs will be NVMe based by next year. And we expect by late this year or early next year that U.2 SSDs will reach price parity with SAS and SATA SSDs in the enterprise space. So we're going to go to audience survey question number 1. So let me get this poll up here and you'll be able to answer it. So I'm going to launch the polling. We'll give you a couple minutes. The question is which NVMe technologies are of most interest to your organization in the next 12 months? This is a multiple choice question, so answer as many of them as you'd like. We'll give you a couple minutes and then we'll go back to the presentation. It'll give you another 30 seconds and then we'll close the polling and you will be able to see the results. By the way, this webinar is being recorded, so all this information will be available probably starting about tomorrow. It'll be on the G2M website. We'll send a link out to everybody who registered so you can see it, as well as the slide. All right, let's go ahead and end the polling. So as you can see, roughly 56% of you are interested in NVMe SSDs, U.2. And it's about 21% on NVMe M.2 SSDs. Add-on cards is about 12%. Servers with NVMe was about 32%. All flash arrays was about 44%. We'll have another question on that a little bit later. Storage appliances, just slightly below that, about 35%. And then NVMe over fabric adapters was 59%. That was the leading one, actually. So very good. All right, returning back to the presentation. So looking at NVMe enterprise SSDs, so as one would expect, capacity is definitely increasing, but it also relates to form factors. So right now, the state of the art for these in M.2 is about 4 terabytes max, which is certainly less than U.2, which tends to max out now. The biggest drive is 16 terabytes. And then finally, PCIe Express add-on card SSDs is about 32 terabytes max. So those are the biggest ones today. In some cases, that's almost a doubling from 6 months ago. Certainly in M.2 on the U.2s. Last report, it was about 12 terabytes, so that one's grown significantly on U.2. And it was about 24 on the add-on card, so it's went to 32. So a fair amount of growth over the past 6 months. The number of models has also grown significantly, with the exception of PCI add-on card SSDs. PCI add-on cards actually has went from 29 models 6 months ago to 27. Not surprising. Our expectation is that form factor will become less and less popular. Obviously, it's not hot pluggable, and its ability to be managed is certainly a little bit less. But if you look at M.2, there's now 25 models that are available in the enterprise space. That's up by 14. U.2, there's 29 models. That's up by 3. And kind of most interesting is the new ruler drives are now available. Samsung and Intel both have one drive each. These are, think of these as elongated M.2s, but they have an enclosure and are hot pluggable. Most of these go on the front panels of systems. Supermicro has actually come out with a server that supports these as well. So certainly an interesting one. We'll see where that's going to take market share from. We'll talk a little bit more about that later. If you look at the growth rate in the units shipped in 2017 versus 2016, you can see that PCI add-on cards only grew slightly. Certainly maybe only about 5%. U.2 grew significantly, and M.2 has also grown quite a bit. Again, talking about some of the limited factors that are driving limited growth of PCI add-on cards. As most people have started to roll out, or most manufacturers rolled out their U.2s, they've tried to standardize the capacity of the U.2s and AOCs. So, with that happening, the advantage that AOCs have for capacity is going away. Certainly, the number of open slots in a standard server is much lower for PCI add-on cards and for M.2 for that matter than it is for U.2. Obviously, for both of these devices, you can't do hot swap. For U.2 you can, and for ruler you can, so we believe those will drive those form factors significantly. And if you're only looking at using a non-hot swappable drive as a boot drive, M.2 is significantly cheaper than add-on card. So we expect those factors, both M.2 and ruler, to start taking away from PCI add-on cards from a market share perspective. Looking at the use cases for NVMe enterprise SSDs, there's several of them that people have seen. As we talked about earlier, M.2 SSDs typically are used for boot devices with the increases in their capacity. We've also seen them used in web servers and compute servers, where the total amount of storage is not great, but they want extremely fast devices. The typical use case is 2 redundant M.2 SSDs in a given server. That's not hard. Most motherboards support 2 of these as a standard. That's pretty straightforward. There's usually not content management issues because it's typically a fixed image. You can update the images. That doesn't happen that often, but it's not like shared storage where we think about where you want to back things up and things. If you look at PCI add-on cards, the historical use case has always been Facebook and distributed databases. Obviously, backing up, migrating these things, there are significant issues which make servers with these things act like or essentially be data islands. Again, we're seeing a drop in the deployment of these, and we think over time that the actual absolute units will drop as well. U.2 SSDs being used in mainline storage, both in arrays and storage appliances, and as well as in servers where the storage is shared across multiple servers to scale out flash storage software. There, generally, the use case is pretty straightforward, replacing enterprise SATA SSDs and HDDs, and over time replacing PCI Express add-on cards as well. One question real quick, let me hit this. One of the audience members asked, is there any prevalence for ruler versus the Intel ruler versus Samsung ruler? I think it's pretty early in the market to say which one is going to take off. I suspect that people will try to make sure that all these ruler form factors are standardized. I don't think as an industry we're in a place where people have wanted to have non-standard form factors. Even in the all-flash arrays, you'll see that U.2 is really took off, which is kind of unique in the sense that previously a lot of the all-flash arrays had custom form factor storage modules. So again, I think it's a little too early to answer the question. We'll have to see over the next 6 months. We also have M.3 that's coming out. It'll be interesting to see where that goes as well. So hopefully that answers that question. From the perspective of NVMe servers, kind of looking at it from the 2016 standpoint, there were servers available from 9 companies, 39 models across 23 series. Not surprisingly, most of these were available from Supermicro. They were by far and away the leader at that point in time. Still the leader as far as the total number of series, but there are other people who are getting very close. Most of these servers had 10 or less U.2 bays. In fact, many of them only had 2 bays in them. What we've seen in 2017 is exactly what you expect. More companies have entered the fray. There's actually 93 different product series or models. All the major Taiwanese companies have entered the market: Taiwan, Gigabyte, Asus are all building actual servers now that they're selling that have NVMe U.2 slots in them. The number of series has grown at all the large OEMs, including Dell and HP, as they've come out with their new Purley-based servers. We've seen a lot more U.2 capable servers coming out with those. We expect the number of bays to average about 6.4 bays in 1U servers. That's not looking based on market share as much as just the ones that are being offered. In 2U servers, it tends to be about 13, just slightly under 14 bays. And again, here you can see the logos of all the companies that now have NVMe capable servers. So it's pretty much representative of the industry at this point. It's becoming fairly ubiquitous. So kind of summing up on the enterprise side, so looking at by the end of 2019, we expect over 50% of enterprise 2.5-inch SSDs will be U.2. I think a lot of this is driven simply by an architectural choice that once you decide you're going to go NVMe, you have to kind of choose between SAS, SATA, or U.2. There are people that offer combined systems or offer board options where you can go one way or another. But we expect over time that most of these will convert over to NVMe, especially given the fact we expect that NVMe will be a price parity with SAS SATA by the end of the year or early next year. And that doesn't mean that 2.5-inch SAS SATA drives will go away. There's a lot of need to actually share things with other people or be able to retrofit old systems that have hard disk drives. So for that reason, 2.5-inch SAS SATA drives will last for quite a while. Couple questions, just hit them on the webinar chat. So somebody asked, is AOC the same as AIC, add-in card, add-on card? Yes, they're the same thing. And the second one is, will we share the slides? Yes, when we actually go ahead and post the video, we'll also post the slides. And kind of a new feature, we're going to start providing you some of our market ecosystem snapshot to everybody who signed up for the webinar. That report will be providing to everybody for free. So you'll see that late next week or late this week or early next week when we post the webinar, the recorded webinar. Speaking of AOC and AIC, as again we said, we expect AOC SSD users or AIC SSD users, depending on which way you like to say it, to migrate to U.2 in the next few years. Last one, I think SOFS may enable M.2 to take share from U.2 use cases. So with scale-out flash software, if you can share the devices and back them up and do data migration, that certainly simplifies things. I think the real question here is what capacity M.2 has to hit to make that compelling, which I would expect to be at least 8 terabytes and probably more like 16. So moving on to all-flash arrays, storage appliances, and NVMe over Fabric. If you look back to 2016, most of the NVMe-based arrays that were out there in 2016 were from startups that were specifically targeting the NVMe market space. In many cases, these had limited data management capabilities. It was more a statement of speed and capacity than it was having some of the data management capabilities that people have gotten used to in the storage space. Some real deployments had started to occur, but largely niche applications. Video was one certainly where we saw a fair amount of those, but not the only one. And in 2016 and even into 2017, most of the major all-flash array vendors were just starting to enter the market. You saw Pure have an array just before Flash Memory Summit last year. NetApp came out with one just before the end of the year, and then, but that was pretty much it for 2017. For NVMe storage appliances, actually, a lot of the ODMs were starting to enter the market, as were some of the SSD manufacturers last year. So that was kind of interesting. And if you look at kind of NVMe over Fabric in that same time frame, it started to become significantly more compelling from the sense of the fact that you had NVMe over Fabric NICs for host target networking, but you still, the number of these that are actually deployed is really limited by the number of NVMe all-flash arrays that were out there in the marketplace. We did see a lot of the all-flash array companies start to utilize NVMe over Fabric as the back-end fabric. These are predominantly NVMe over Rocky Ethernet-based adapters. But we did start to see at the end of last year an explosion in the number of NICs that supported these as people started coming out with multi-port devices, different form factors like Open Compute Project or OCP adapters and things like that, and different speeds. And the other thing we started to see last year was really the availability, not just announcements, but actual availability of accelerated or offload NVMe over Fabric, either FPGA or system on a chip-based adapters. So looking at this year, at this point, every major all-flash array vendor now has an NVMe array in their portfolio. Dell EMC, MAP, and Pure Storage have one or more. Dell actually has several of them, as does NetApp. And most of these have NVMe over Fabric interfaces as well. Other storage companies have started to include them in their hybrid arrays. We generally don't cover those. From our perspective, the architecture of these generally is still disk-focused and doesn't get quite the performance. I think that would be a true statement in Flash in general, but certainly for NVMe, it's a very true statement. But there are a lot more people starting to use these again. Especially in the video area, we see a lot of people starting to use NVMe drives and NVMe over Flash or over Fabric to connect their drives to hosts. NVMe storage appliance market is also maturing. As we said earlier, there's 21 models that are directly built for the storage appliance market that incorporate NVMe drives. Many of these are also being offered with NVMe over Fabric interfaces. And since these cards are basically going to PCI slots, it's really a matter of what software manufacturers support. So we expect NVMe over Fabric to take off in this market fairly quickly. Scale-out flash storage, we're finally starting to see is getting traction with customers and OEMs as well, with several reference designs coming out supporting a variety of these different adapter form factors. For NVMe over Fabric, getting design wins is really in high gear. We see a lot of competition for all-flash array vendor slots from the NVMe over Fabric vendors. Interesting enough, NVMe over TCP is starting to get more support as an alternative to NVMe over Rocky. It'll be interesting to see where that goes. NVMe over TCP was originally thought of as a way to provide management capabilities to NVMe over Fabric-based systems, but its use as a standardized transport is actually starting to take off. So we'll see where that goes over the next 12 months. And as we talked about earlier, NVMe over Fabric accelerated adapters are starting to really be deployed in all flash arrays at this point. If you look at the ecosystem today for NVMe over Fabric adapters, there's 59 models of adapters from 9 different companies. If you look at the standard host target connect NIC or RNIC market, companies are Broadcom, Cavium, Chelsea, and Mellanox. And as we said earlier, SolarFlare entered the market this year with the launch of their X2 adapter, which has NVMe over Fabric using NVMe over TCP. Mellanox adapters also support InfiniBand for NVMe as well. On the fiber channel side, both Broadcom and Cavium, not surprisingly, have adapters. These are generally their Gen 6 adapters, which are available at 32 gig and in some cases 16 gig. Accelerated Ethernet adapters, in other words, the FPGA or SoC-based designs that are typically used as target devices are available from Aperion, Atala, Broadcom, Calray, Kazan, and Mellanox. These generally tend to be focused on high performance. In some cases, they are used to actually run JBOFs and provide the management capabilities in those, in addition to being just simply NVMe over Fabric adapters. If you look at 2018 and the potential for growth in this market, I think there's a variety of factors that are actually going to help improve the NVMe over Fabric market adoption. We talked about NVMe over Fabric being picked up by the major array vendors. They'll certainly will have a big impact on that. NVMe over TCP and routable RoCE, I think, will both be important factors driving that, as well as soft RoCE, which gives the possibility of running NVMe over Fabric on adapters that are not designed for hardware-based or firmware-based NVMe over Fabric. Because of this, we expect to see significant deployment of NVMe over Fabric in the 2019 timeframe. From the NVMe storage appliance standpoint, again, we talked about a fair amount of growth here. There's one new company has entered, actually two new companies have entered. One has left the market, but the number of products and models has grown by 8 from 13 last year to about 21 this year. So a significant amount of growth there. Again, I think one of the things that's interesting in this market is that for most of the people offering NVMe over flash storage appliances, they're still offering multiple interfaces, whether it's the iSCSI, NFS, CIF, CEF, Swift, are also being offered, as well as NVMe over Fabric block-based storage. Many of the customers are using NVMe for future-proofing performance capabilities, and the PCI slots and the storage appliances certainly allow the flexibility in the future to allow these storage appliances to be retrofitted with more NVMe over Fabric over time. From a scale flash storage standpoint, last year we had two companies that were really starting to make some progress, Elastifile and Accelero. They've been joined by Weka.io. There's also some of the companies that have built disk drive or hard disk drive based software-defined storage, such as some of the ones that are out there, Datacore, some of the other ones like that, that are starting to actually, Accent is another one that are starting to actually look at NVMe over Fabric through NVMe as well. Interestingly enough, some of these storage appliance vendors are actually starting to use the Scale-Out Fabric software to provide complete solutions, even in the form of reference designs, or actually offering it as an OEM option. So a lot of exciting things happening there. So let's go to the second poll question. And that question is, come up here and launch it. So what factors are more important for your organization in deciding whether to deploy NVMe-based shared storage? And that could be all NVMe-based all-flash arrays, it could be NVMe storage appliances, or it could be servers connected up with Scale-Out Flash software. I'll give you a couple of minutes to answer this question. This is, again, it's multiple answers, so you can choose multiple answers that fit your needs. Okay, we'll give everybody another 30, 45 seconds, and then we'll go ahead and post the results. All right, we'll go ahead and end the polling. So one of the number one result, which you guys should be able to see now from the questions, was interoperability test results for NVMe over Fabric adapters and switches was the number one answer, followed by use cases from customers and other customers in our space. Number 3 looks to be cost parity with SAS SATA-based all-flash arrays. Excellent. All right, let's kind of wrap up the webinar here. So we've said this statement before. I think it bears stating again. NVMe is really, it's not like a lot of other technologies. I remember when InfiniBand came out, people thought it was going to be the new Fabric, and it struggled a bit before it found its foothold in the HPC space and some of the other spaces where it's gotten a foothold. I think NVMe is different. I see it as inevitable. It's really the way Flash is going. It's going to replace SAS and SATA, and I think once you see that foothold happen, the idea that it will also replace, NVMe over Fabric will be the predominant interface for storage comes pretty directly with that. I think in spite of the introduction of Rula and some of the other form factors, I think U.2 for some time will be the most popular form factor for NVMe SSDs. Over time, 5 years from now, that could change. but I think certainly through about 2021, it should be the most prevalent form factor. Third point, I think NVMe all-flash arrays have finally reached a tipping point with the introduction of arrays by all the major vendors. I think you see a lot of traction there, and that's going to help drive both the all-flash array market for NVMe as well as the actual NVMe over fabric market as well. So that's an important point. It'll be interesting to see how much of that actually continues to happen this year. And along those points, obviously NVMe over fabric, a lot of interest by the vendors, obviously, a lot of new products out there. But in the end, you've got to have targets to talk to, whether they're all-flash arrays or storage appliances. Without that, NVMe over fabric as a connection really is interesting, but not much more. So as these all-flash arrays become, we see more deployments of those, and storage appliances using NVMe, I think you'll see NVMe over fabric take off, in step with that. One trend that we've seen that certainly NVMe over fabric certainly helps enable is the disaggregation of storage systems. And that can take a couple different forms. I think we've seen in arrays, if you look at what companies like Cam and Aereo have done, where they're really disaggregating storage controllers from the storage shelves and then connecting them through a fabric, a back-end fabric that ends up being NVMe over fabric. That's one approach. The other is using scale-out flash software and actually connecting a bunch of servers or a bunch of storage appliances into one large namespace. So both of those things, NVMe and NVMe over fabric will really help enable, and so we'll see that happen more and more. The last one, I said this a couple slides earlier, SAS, SATA, flash, and hard disk drives will be around for a long time. From a hard disk drive standpoint, there's a lot of things you can do with storage now that they're really being focused on high capacity and not as much on performance. You see a lot of the manufacturers slowing down the speeds of the drives. That allows them to have higher density. It reduces the error rates. And so for cold storage or even some forms of warm storage, hard disk drives will still be one of the most popular ways of storing that data from a media standpoint. Certainly SAS SATA, we talked about that as a replacement for hard drives. Certainly in desktops and laptops, it's very popular, as well as in servers. You still get a lot of the flash advantages of more speed, as well as more predictable reliability. So we think those are important factors that will keep those going as well. So here I've got, you can see my contact information. If you guys have any questions, please feel free to send them to us. We'll go into the Q&A for a second, but again, we're going to post these slides and the recording onto our website in a couple of days, and everybody who registered will be sent an email with a link to that. So with that, let's go ahead and get started on the Q&A. The first question was, what OS platforms are the drivers for NVMe over Fabric being developed? I assume what the questioner is saying is, for what OSs are drivers for NVMe over Fabric being developed? We see them both in Linux and in Windows. We've certainly seen both of those out there. That's not to say that ones aren't being developed for things like some of the other Unix-based operating systems, like AIX or Solaris. Certainly if you saw Oracle, it has a lot of models of servers out there, many of them which are Spark-based servers. So we expect to see more and more of those to actually, more operating systems being supported. I don't know of any being developed for Mac OS. That's not to say they aren't. I just don't know of any, but I would expect that as NVMe grows into the video space, we'll see more of those as well. One of the other questions, can we get the slides after the webinar? Yeah, we'll post those on our website, and you'll get a link to them when they're posted. Next question, what do I think of FC-based NVMe over Fabric? I think for companies that are fiber channel based, and just for a piece of history, I've worked for all three of the fiber channel adapter companies. during my career, so I'm really familiar with fiber channel. For companies that use fiber channel, you look at big financial services institutions, a lot of the Fortune 500s that really rely on it. I think NVMe over fiber channel makes a lot of sense, and it provides a lot of speed advantages if they're already running a Gen 6 fabric. It's an easy transition, so I expect those companies will go that way. I do expect that NVMe over fiber channel will extend the life of fiber channel significantly, so I think that's good. That said, I think that, as we've seen in general, I don't expect new organizations that don't have experience with fiber channel to actually deploy fiber channel solutions. That's a trend that we've seen over the past 4 or 5 years. It's largely the people that have it that continue to. I don't think NVMe over fabric necessarily changes that dynamic. Another point, NVMe is so much faster that write cliffs on SSDs may be approached much sooner than SATA SSDs. Absolutely a true statement. Certainly, if you think about a server, even 4 SSDs, NVMe SSDs, can max out the PCI bus in those servers. And that's been one of the things that's been driving people to look at alternative architectures, such as computational storage, where people actually embed computation capabilities within SSDs. I think we'll see other things as well, but very good point. It is something where, it's funny because I remember growing up in the world where disk drives were the slow piece of the equation, right? And servers and networking were the fast ones. Flash came out, the network became slow. Then we had 100 gig networks, and in the case of fiber channel, 64 gig. And at this point now we're back to the servers kind of being the slow point, or certainly the PCI Express bus. So we'll see how PCI Express 4 and 5 change that, or if some other more radical change to server architectures happens to address this issue. But very good point. Thank you. Last question that we have is, can you speak to which markets are seeing early adoption of NVMe, high-end, entry-level, etc.? So that's a really good question. In almost every market where NVMe has taken off, it's been the use cases that have driven it. There's certainly a lot of interest in the video space. If you think of big data and analytics, that's been another space where NVMe has had a lot of progress. Certainly databases in general has been one as well. A little less so in, say, in the entry-level markets. In fact, if you want to bifurcate the servers that are being offered with NVMe, they tend to be higher-end servers. If you look at low-end servers, they tend to still use SATA, even if they do offer flash. So it's generally been higher-end markets, specifically ones where that performance has been very important. Okay, we have one more question. When do you see the transition to fiber channel to Ethernet for NVMe over fabric? So just to expand a little bit on the previous answer, I'm not sure that we see that. I think the one thing that you have to remember, and this is an important one, is the difference between fiber channel and Ethernet when it comes to a storage fabric or a SAN isn't just simply the fact that it's a different technology. It's also the fact that you have, in the case of fiber channel SANs, what is a dedicated SAN, right? It is dedicated specifically for storage. It doesn't carry standard network traffic. Ethernet-based SANs, on the other hand, overwhelmingly are converged fabrics. So they're fabrics that carry standard LAN traffic as well as SAN traffic. So it really comes down to the question of at what point do end users or storage architects feel that they can still get the performance they need out of a SAN if it's a converged SAN versus one that isn't. Some of the factors that go into that, certainly quality of service capabilities or constructs, which continue to get better in the Ethernet space. You also have concerns about congestion. Even with 100 gig Ethernet, congestion is actually one of the biggest concerns that is out there right now. There's a lot of people working hard on approaches and architectures to minimize the potential for congestion, or work around it in those 100 gig fabrics. So that's certainly another factor that can slow that. If all those were taken care of, certainly could enable that transition. But I think those are probably the biggest, or that single biggest factor is, do you as a storage architect want to have a dedicated SAN that only does storage and isn't interfered with by other LAN traffic, or do you feel comfortable going to a converged SAN LAN approach? All right, that's the last of our questions. Again, thank you for attending our webinar. We'll make sure you get the link. That should go out in the next day or two. So stay alert for that, and that link will have the link to both the recording, the slide set, and the NVMe market snapshot report as well that will be available to all of you. And if you want to share those with other people that are out there, you can certainly share the link, and they'll be able to download as well. But thank you very much, and have a great day.
What they all similarly do is they take a problem, much like HPC did for years and years. They take a problem and they divide it up into multiple hosts. And we've applied, for NVMesh that is, that same methodology for the storage platform itself. So rather than putting our intelligence in servers, such as, Sanmina has some very nice offerings for servers, yet at the end of the day, they are restricted by the designs that they get from either Intel or AMD. That is, if you're connecting NVMe drives and you're putting networking on there to access those, you're limited by the number of PCIe lanes. You can put expanders on and you can stuff it in, but you're limited by that CPU architecture. So we believe that you have to be really, really flexible and allow drives to be spread over many, many hosts. Use those as if they're local, because the intelligence is within the client side itself, or the initiator. So we spread out the intelligence of our logical virtual all-flash array over all the clients themselves. We don't tax the CPUs of the targets at all. We literally, without a specialized hardware card, we completely offload the transport on the target side. So this enables what Tom touched on when he talked about convergence. You can literally have your application servers with NVMe logically disaggregated. Dan had mentioned the importance of being able to disaggregate, and we 100% believe that. Only we can deploy physically disaggregated, where you make servers just be storage, or we can logically disaggregate, where you have NVMe in each server, and we don't tax that server for remote people using that NVMe. We literally put 0 CPU load on. And so I think, to go back to the question, the key thing as you get these scale-out solutions and design now is to design in the true philosophy of scale-out, and that is distribute the processing, don't put the intelligence in central controllers. Really take advantage of the fact that every single server has a whole bunch of cores and a lot of processing power, and the aggregate of all that is much, much higher and more valuable than locking down in centralized controllers. That's it.
Perfect. Thanks, guys. Let's go ahead to the third question. This is one that I've heard from a lot of people looking at NVMe in general and scale-out flash as well. But what do you see as the killer apps for a scale-out flash solution, and what are the best practices for maximizing the value of scale-out flash solutions for these use cases? And we can spend a little extra time on this since the audience polls aren't apparently not working. So, Dan, I'll start with you at Nuisis. What are your thoughts on killer apps for NVMe and for scale-out flash?
Okay, thanks, Mike. So we have two thoughts again. There's sort of the first thought is from the enterprise perspective, and then the second thought would be around, talking a little bit more around specific example in a little more detail. So, obviously there's many killer apps that we see emerging with our customers. We sell across platforms to the hyperscale folks in very large fashion. And the four areas that are worth highlighting right now would be, the first one we see is big data analytics applications. So these are the things you'd expect: artificial intelligence, machine learning, IoT. The second is virtualization and container infrastructure, addressing the high performance requirements of applications across distributed data centers and private public cloud deployments. Third would be OLTP, to address the core mission critical applications that demand the highest levels of performance, scalability, low latency, coupled with the requirement for non-disruptive operations. And then the fourth piece is business continuity, solutions for nonstop operational systems, which typically need scale out in an overall enterprise framework to address the on-premise data center integrated to cloud storage environments of the hybrid model. So these, the best practices around this, I'd say there's sort of 5 key considerations. There's certainly many more, but sort of 5 key that are worth hitting on. Service level objectives of the customer for the overall performance of the entire workload, and QoS of specific applications to meet customer performance expectations is one of those. Having a retention strategy of information assets and lifecycle management of data from creation to long-term archive. Also, high availability and capacity on demand with scale-out design that can non-disruptively address adding capacity or new levels of software with no planned downtime. Fourth, data protection addressing all aspects of security information assets from disaster with snapshots, backup, and replication between the on-premise and cloud storage infrastructure is also very important. And then lastly, global security and access control with the ability to address corporate governance, regulatory mandates, and privacy protection utilizing encryption, key management, multi-tenancy, and other techniques is also one of the 5 important considerations. So, the future for scale-out flash storage will incorporate all of these best practices along with unified storage strategy that can address any data type, including files, databases, objects. Without scale-out design for these killer apps, customers historically had separate systems for each type, and that was very expensive and added tremendous CapEx cost as well as OpEx. So, when I think about this, and we talk about this also from the perspective of an example, a killer app for scale-out flash storage is real-time data analytics, sometimes referred to as big data or fast data applications. This killer app relies on 3 vital functional components to meet the requirements. You have to have high throughput storage for data ingestion. You need to have distributed in-memory database for data processing for this particular application. And then thirdly, you need low latency, high bandwidth networking for clustered servers. So, with New ISIS, we have a storage solution that overcomes these challenges so that enterprises can break through today's memory limits, enabling new possibilities like accessing higher capacity in-memory data sets to deliver better, faster analytic insight. An example of this would be, cloud providers can reduce capital costs for memory when allowed to oversubscribe their workloads with greater overall capacity. Or high-performance computing centers can increase large memory data sets to improve research and scientific results and test new simulations quickly and cost-effectively. So scaling these deployments involves the addition of server nodes to expand the aggregate amount of memory RAM available in the cluster. But adding servers unnecessarily increases compute CPUs, and this negatively impacts return on investment. So for this sort of killer app, New ISIS has a real-time analytics engine solution that overcomes this dilemma by allowing non-volatile memory, NVM, to complement RAM to expand the addressable memory available for server nodes running in-memory databases. So we can expand beyond the box. We actually have a planned demonstration at the Flash Memory Summit coming up in 2 weeks, where we'll be, hitting on the following killer app. We've just taken, again, third-party interoperable components, tied together a solution that is industry-leading, high performance, and pretty compelling. So in this particular example, we've got one of our New ISIS storage servers that's serving as a Kafka distributed streaming device. We've got one of our new NVMe Optane storage array, so full of Intel Optane drives for memory extension via the Intel Memory Drive technology, IMDT. We have to use an MP Store software package for persistent storage as part of this. And then we have 2 industry standard servers for just running MemSQL in an in-memory database clustering. And then we have some Mellanox switches. So you can see components from all these vendors providing an integrated, incredibly cost-effective, and terrifically high throughput performance sort of leading edge solution there. So the benefits of this real-time analytics engine is that it includes greater scalability at lower prices and low impact performance versus an expensive memory-based solution. For example, this demonstration will show a reduction in cost of less than 50% versus it'll cost less than 50% versus conventional RAM-centric solution while delivering over 85% of the equivalent performance. So this is, just understanding the customer needs and providing a solution that gives you a dramatically better, overall, more efficient package and solution in a cost-effective fashion. So that's sort of our view there. Thanks, Mike.
Thank you very much, Dan. Josh, obviously you guys are right in the middle of this. What's your kind of view on killer apps, and what do you see your customers actually utilizing scale out for?
Well, it's going to be hard to follow up on Dan's answer because he covered an awful lot of it. So rather than just say ditto, I will reiterate that I do believe in a lot of the use cases that Dan pointed out. And it's a lot of the buzzwords, so I don't want to just rattle off buzzwords. But yes, real-time analytics. Video analytics is something we see because of the massive bandwidths that we can do and that scale out can do. Very large databases. And AI and machine learning, absolutely, positively. But you might be sitting listening on the other end of this conversation and say, well, yeah, I do those things already, but I just put local NVMe inside the servers. That's how I do it. If you were deploying any of these in-memory databases, for example, take your pick, Cassandra, HBase, Mongo, any database that counts on having a lot in memory, best practice for that database is to go ahead and put a local flash device, and you'd probably want to choose NVMe with that database. And that's because during startup, it's going to read from that drive. During shutdown, it's going to dump to that drive. And if there's any in-memory table misses, or the database expands beyond the physical memory of the system, it's going to go ahead and use that drive. So you want the lowest latency possible. So ask yourself, do you really want to have to choose a certain size drive? Do you want to have the limitations of the physical hardware? And that's what I think is important. Any application for you is a killer application if you have decided that you have to use NVMe flash. If you're putting NVMe flash in your servers, but you don't like the physical limitations of that, you don't like to have to choose servers that take NVMe, you can buy systems from Sanmina. You can contact Dan, and you can buy systems that take either Optane. We've worked with Optane remotely. We do 14 microsecond remote reads and writes against Optane media. So if you want to go ahead and extend virtually the memory of your system, go ahead and use us and use Optane and get 14 microsecond remote reads and writes. And yet you can also then choose to have redundancy if one of these drives fails. With automatic failover, you can have host failure. So the killer app is whatever you want it to be, where you've chosen to use local NVMe. But best practice would be to break the bonds of physical locality, allow it to be remote. Operationally, allow you to use a particular type of server that can be serviced, whereas your compute nodes can be any form factor. They just need to be able to take a network card. Go ahead, use your killer apps, whatever they may be in this space, but instead of doing local NVMe, do remote and have the same speed access. And the best practice basically is to match your NVMe drives to your network bandwidth. And then you're going to extract all the dollars you pay for this expensive media. You're going to be able to use it remotely and get every bit of IOP and throughput performance out of that. That's it.
Excellent. Thank you very much, Josh. That was a great answer. Scott, finishing up with you. What do you guys see as killer apps for scale out?
Well, following Josh and Dan isn't going to be easy. I was going to say big data analytics too, also combined with AI and machine learning, because data at the end of the day has to serve the companies that are collecting it, right? If we take a look at some of the more easily recognizable, understandable things that everybody can latch onto, we look at things like Siri and Alexa, right? Both of these are huge business drivers for Apple and Amazon, right? But when you boil it all down, the concept of taking an audio fragment that you recorded, shooting it up to a cloud, processing that audio into some sort of natural language, then doing a natural language query to figure out what the heck they really are looking for, and then taking that query and turning it into an actionable bit of work is a huge amount of processing power, and it requires many servers to do it. Just taking the concept of Alexa, reorder dog food, and imagining how that turns into food for Fluffy over the next month is just a non-trivial amount of computing power. And people expect an answer in a few seconds. I mean, if Alexa doesn't get back to you in 3 or 4 seconds, you're like, oh, wow, is my network working? Is Alexa doing her thing? I mean, the human factors of this are really important. So being able to, reduce latency at every turn is important to this whole process. And this goes beyond obviously just, Siri and Alexa to things like facial recognition and self-driving cars and object recognition and all that. All this stuff takes enormous amounts of compute power and dozens, in some cases, hundreds of servers to make that happen. So every time the data, enters and leaves a server, there's an opportunity there, at least, from a Solarflare perspective, to reduce the latency of that transaction. And we can shave even, a microsecond here or there. They all add up at the end of the day. So latency really does matter, especially in the NVMe space. And Solarflare is probably the best partner you have on the networking side to make that happen for servers. So that's kind of our take on the whole big data angle to reduce some latency. Thanks, Mike.
Excellent, Seth. Thank you very much. Great answers, everybody. Now we'd like to open up to audience Q&A. If you have any questions, please use the Q&A window on your Zoom to post that question. I'll read it off, and then we'll let the panelists each take a shot at answering it. So go ahead, and if anybody has any questions, please go ahead and type them in. And just as a reminder, we will be sending out a link to everybody who registered for the webinar, so you can see the recording and the slide set. That should go out within 24 hours of the finishing the webinar.